All right, so what we're going to do is we are going to watch a few snippets of videos from Khan Academy on equivalent fractions. I really think they do a really good job of showing the different models. And so we're going to watch those together, and then there are going to be some pieces that I want you to actually practice. So I'm going to play that video. I'm going to stop at a few places and kind of piece us the different things that we need. Okay, and then I'll cut in and explain a few pieces for you.
What I want to do in this video is really digest the idea that if we have some fraction, as long as we multiply the numerator and the denominator of the fraction by the same number, that we're going to have an equivalent fraction. So let's think about that. Let's say we...
Okay, I'm going to pause that right now. Right here, I want you to realize that this 6 right here is the denominator. It is how many total pieces you have, okay? And then your numerator, your top number, that's how many are shaded in this story. And then a lot of times in your word problems, it's like how many pieces they ate or they used or how many pieces are left. So depending on what the problem asks, your numerator can stand for a different thing. So, but your denominator is always how many parts make the whole.
We multiply the denominator here by 2. Let's say we multiply the denominator here by 2. I'm claiming that as long as we multiply the numerator by 2, that we're going to get an equivalent fraction. So here, the denominator was 6, so here our denominator will be 12. If our numerator here is 4, well, we've got to multiply by 2 again. Multiply our numerator by 2 to get 8. So I'm claiming that 8/12 is the same fraction as 4/6. And to visualize that, let me redraw this whole. But instead of having 6 equal sections, we now have 12 equal.
Okay, so the reason he's got to cut this and make 12 equal sections is, again, because of this denominator. So if we have 6, well, we know that if we just cut these 6 in half, that would give us 12 because 6 times 2 gives us the 12.
Sections. So each of the 6 we can divide, we can turn into 2. That's essentially what multiplying by 2 does. We now have twice as many equal sections. Now that we have twice as many equal sections, literally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, how many of them are actually shaded in yellow? Well, 1, 2, 3, 4, 5, 6, 7, 8. 8/12. So there's no magic here. If we have twice as many sections, we're going to have to shade in twice as many of them in order to have the same fraction of the whole. And it goes the other way too. This isn't just true with multiplication. It's also true that if we divide the numerator and the denominator by the same quantity, that we are going to have an equivalent fraction. So that's another way of saying, well, what happens if I were to divide by 2? So if I were to divide by 2, let me divide by 2. I'm going to have half the number of equal sections, or I will only have 3 equal sections. And I'm claiming if I do the same thing in the numerator, that this is going to represent the same fraction. So 4 divided by 2 is 2. So I'm claiming that 2/3 is the same fraction as 4/6 as the same fraction as 8/12. Well, let's visualize that. So here, this is 6 equal sections, but now we're going to have only 3 equal sections. So we can merge some of these equal sections. So we can merge these 2 right over here, and we can merge these 2 right over here, and then we can merge these 2 right over here. So our whole it's still the same whole, but now we only have 3 equal sections, and 2 of them are actually shaded in. So these are all equivalent fractions. So the big takeaway here is start with a fraction. If you multiply the numerator and the denominator by the same quantity, you're going to have an equivalent fraction. If you divide the numerator and the denominator by the same quantity, you are also going to have an equivalent fraction. So with that in our brains, let's tackle.
Okay, so let me pause this real quick and okay, so let's practice a few of these where we just have the number of what we just watched. So again, whatever you do to the bottom or the top, whatever you do to the bottom, you do to the top. Whatever you do to the top, you do to the bottom. So if we look right here, what did I have to do to 1 to make it turn into the 2? Well, I would have multiplied. So 1 times 2. So I multiplied by 2 right here. That's an awful multiplication sign. Times 2. And what I do to the bottom, the top, I must do to the bottom. So then 2 times 2 would mean that that P is going to equal 4. So let's check that answer. Okay, so let's try another one. Here we go. What would I do to 2 to turn it into 4? Well, I multiplied it by 2. So 2 times 2 is 4. So then 1 times 2 would be 2. And again, we're just checking to make sure we understand that we are multiplying the top and the bottom by the exact same number. Let's try one more. What did I do here? I multiplied 2 times what equals 6? Well, 2 times 3. So then 4 times 3 would give me 12. Okay? All right. So the next thing you're going to do is I want you to you're going to go to the Google code that I'm fixing to give you, and it's going to bring up a game that I want you to play. But I want you to practice that right here. So let me. All right, so what we're going to do is stop this video in just a moment, and I'm going to give you a link in your Google Classroom that you are going to practice. So I'm going to come back on with a little short video to show you exactly what you're going to do with that. Okay, so click the next video on your Google Classroom to see how to do that.